In this section, we'll be talking about enums and structs. You'll find out that when you're writing smart contracts, so let's look at example smart contracts. You will see here, this is what an enum is. So you see enum data key. You see, and so it's being used here. For example, environment or storage or instance or set. Don't worry if you don't understand how it works. I will show you an example in Rust, but this is an enum. An enum is just this structure that kind of like holds these items inside of it. So you could see, so in the smart contract here, we use it as keys. If you are familiar with a dictionary in Python, if you're coming from Python, a hash map, so the key of the hash map that is used to store a particular value. So that's what you see most of the use cases in Soroban, how they use enum. The contract itself, even from the Hello World contract here, you discover that the contract itself is a struct. So let's see struct and enum in action with a very simple Rust example. So let's create an enum and see how enum works. So we're going to be creating an enum here. So we're going to say enum, and then we're going to call this enum called direction. So we're going to call it like direction, and it's going to have like, let's say, up, down, left, and right, just like this. So you see, so we just created an enum here. So we created some directions up, down, left, and right. So let's see what happens here when we decide to print. Let me take this result out, or I could just leave it here. So let's see what happens when we decide to print the value of the enums. Let's say let my direction, so my particular direction equals to right, just like we see here. So you see, so this enum, we've been able to access the right here. So by saying let my direction equals to right. So let's kind of like print the value of this enum. Let's see, for example, print. Let's see what will happen. Let's see. We're going to be printing like our direction. So if you notice, I can't print the enum like this. So I can't just say, I can't just print the enum like this. And the reason why I cannot print the enum like this is because enum doesn't support debug. So for something to be printed here, it needs to have this debug trait implemented for it. More or less like this particular type doesn't have the ability to print it. For now, just take it like that. So what I could do now to make that happen is to put a column with a question mark like this. So you see, and I think this could go, let's see. Let's try to print it and see. So we still get could not compile. I think the problem here is that, so look at one good thing about the Rust compiler. It's actually telling us what to do. So that if I put this one here on top of the enum, and you will see that in most of our smart contracts that they will always kind of like, when you do this, it's more or less like it's writing some code, additional code to support this particular structure to be printed. So you see here now it works, and look at what happens. So we have hello world right. The direction was printed here, so it was hello world right. So what you could do here is that in normal Rust program is that, for example, you could decide to use what they call the match keyword to match this direction. For example, you could say, let me show you this example. You could say, for example, you could use the match. So more like match, and then you could say what value are you by my direction. So now you see you could put like if your direction is not. So you could say, for example, if my direction is down, and then you could say print down, and you could do that for all others. So you could say if my direction is left, print left, and then you just accept for all. So you see, so now it will print whatever direction. So this match will execute based on the particular direction that we have here. So for example, we know it's going to print right. So let's see that in action. So you see we have right. You see right got printed here on top here before the hello world right. So this is how enums work. So enum basically is just I think it helps you, for example, in situations where you don't want to kind of like hard codedly. Maybe, for example, you want to define like errors, and you want to say, for example, authentication error, another type of error, maybe unaccessible error. So you want to define all your errors and have them defined so that when you are using them, it's easy for you to is readable and understandable. So let's look at struct. So struct is similar to, in 80% of the cases, with the help of struct, that's how you'll be able to hold your data structure. So let's define a struct, for example, called rectangle. So I'm going to be defining a struct here. So struct is how you hold your data. So for example, I want to call this struct rectangle. So this is how you hold your data. So we have a width and we have a height. So in this case, let's kind of like define a rectangle here. So let's define a rectangle. So we're going to say, let my rectangle. So then this is how we're going to define it. So we give it some width and we give it some height. Now we could decide to print. So we could decide to print the items in that rectangle. So another thing you could see most often is that the struct can also give you the ability to implement functions that work on the type you're seeing here. So for example, you see them do this implementation for rectangle, and then you could define a function, for example, here, like area, for example, and then you could have the area of the rectangle printed, like, so you would have this function return the area of this rectangle, and then you could, for example, come here and do something like let area equals to rectangle.area, and then of course you could print the result like this. So this is how you will see in most of the cases. Your smart contract itself will be a struct like this. So you have a struct, for example, called my contract. So this will be a struct. So this will be like your contract. And then you will have an implementation for your contract where you expose methods that work on the data inside of your contract. So basically, this is how, in most cases, so struct are one of the most powerful features you'll be using. So your ability to use both enums and struct will be very vital as you write your Soroban smart contracts. So we are going to be looking at ownership and borrowing in Rust. So Rust has this unique ownership system model that ensure each value has a single owner. So for example, each value in Rust has a variable that is called its owner. And a value can only have one owner at a time. When the owner goes out of scope, the value will be dropped. So you're going to see that in action. So we're going to, I think we will not cover more of lifetimes for now, but you will see how the borrow checker works to enforce this memory safety, preventing common programming errors. So, for example, if we make the mistake, our program will not even compile. So let's go to our IDE, to Visual Studio Code, and see how Rust ownership system works. So we are coming back to the same project we were working on. So in this case now, I'm going to be creating a variable. I'm going to be creating a string here. So let's create a string called S1. So let's say S1 is equals to. So we're going to be creating a string. So the way you create string, we're going to be creating a string using this function. So we're going to say string from, and then we're going to be passing the value. So the value here, so we're going to be creating it from this. So now we have this string. So this is a string. This is how you create string. So in other languages, for example, if you define like let a be equals to, so when you say this, let's say you say hello here. This is not a string, but a string slice. It's more like a section of a string. So this is how it works in Rust. So we will look at types much later. So this string we've created. So in Rust, you cannot do something like this. So if you say something like let, so you create another variable called s2 to be equal to x1. So what has happened here is that s1 is no longer valid. So let me call it s1 so it's clear. So you see now we have s2. So now s1 is no longer valid. So let's see what happens when we try to print s2. So let's try to print s2. So let's say print S2. This is going to work. So let's see here, we're going to print S2. S2. So this is going to work. There will be no problem with this. So this is going to run. So let's see. So we get the value hello printed. But the problem is going to come. So because S2 has taken over the ownership of S1. So you see, S1 is the one that owns this value, but we transferred this ownership to S2. So now when we come here and print S1, we're going to have an issue here. So you see, the borrow checker is already checking it here. Say borrow of move value X1. Value borrowed here after move. You see. So now when we execute our program, it's going to crash. You see, it's going to crash. So, and it's also giving us a solution that if we want it, rather what we should do is to clone the value. So we should clone this value. So you see, now when we execute this, you see everything is fine. So basically here, in Rust, when you create a value, particularly a value that is in the heap, you cannot just assign that value to another value. You cannot just use it multiple times like you do. Although you could do it with like primitives, like the like small values that are not that are their size are actually known at compile time. For example, you could say, for example, let b be equals to, so we could say, for example, something like 34 here as a value. So this one is an I32. So we can also say let c be equals to b. So in this case, you will notice that there is no problem here. So we can decide to print both b and c. So we could decide to print b here. We are not going to have a problem with this setup. So the reason is because, so look at it. You see, I'm not just looking at the whole error messages that we have. So, but you see, everything got printed here. So 34 got printed here. So there was nothing like B got moved to C. So because these types are small enough, they are stored in the stack of our program. So, but when you talk about string and those custom types like rectangle that you're going to be defining, these types are going to be stored in your stack. And because of that, you cannot just move them. So when you say, for example, S2 is equals to X1 without cloning that value, what happens is that the value of S1 get moved to X2. And now S1 is now not valid. You can't print it. The only way you could do it, for example, to solve the problem, is to clone S1. By so doing, you can print S1 now because S1 is not moved. This is not actually this this value is actually a clone value of S1. That means a section in memory was created to store this value as opposed to S2 pointing to the memory where this string was stored. So this is how kind of like ownership and works in Rust. So we will look at borrowing by actually defining a function. Let's say we define a function here that takes a string and kind of like returns the length of that string. So let's say, for example, we define a function here called let's say we say fn, and then we call this one calculate. So we're going to call this one calculate length. And what we're going to do is that we're going to pass it a string, and then it will return the length of that string. So you see, so what we want to do now is that if you notice in this function, look at what is happening. We are not passing the string, we are defining the function here. So this is what we call borrowing. We are passing a reference to that string to this function called calculate length. So when we come here, for example, and decide to use it from x1 now and say, okay, our length, let's say, for example, let length be equals to calculate length. So you see now, this is fine. The reason why this is fine is that this value did not get moved because we only provide a reference to that value here. So you see, this is perfectly fine. So, but what would have happened is that we would have to run to the same error, for example, when we decide to pass in S1 here. So when we decide to say, for example, we are passing a string here. So we are passing this string here, S1. Now you see here, there is a problem because the value has already moved. It's not even available here. It's not even available here. So this is the concept of ownership and borrowership. So you will see it in our Soroban contract that in most cases, we will just have to clone, let's say, for example, a value because we don't want it to it was moved. To prevent it being moved and not available for downstream operation to use that value, we will just clone the value. So this is the end of this part. So let's move to the next one.